Now in this lecture we are going to implement coin change problem in Java. So the first thing that I'm going to do, I'm going to create a separate file for implementing coin change problem class. So here I'm going to create a new file and I'm going to name the file coin change problem.java. Then inside this file we are going to create our coin change problem class. So the first thing that I'm going to do, I'm going to import arrays, because in this case we are going to use arrays inside this class. So I'm going to import it from Java util library. Then I'm going to declare our class like this. Public class coin change problem. So inside this class we are going to declare coin change problem method for solving coin change problem. So here I'm going to declare our method like this. So the method will be like this: static void coin change problem. So here I'm just going to put with the small letter. Then this method will take two parameters. So the first parameter will be the array of the coins. So in this case it's going to be the type of integer. So I'm going to name it coins. And the second parameter will be the total amount. So in this case this one also will be the type of integer. So I'm going to name it n. So here the first thing that we are going to do, we are going to sort coins inside this coins array in ascending order. So I'm going to sort it like this: arrays dot sort. So I'm going to put over here as a parameter coins. So with this we are sorting our coins inside this array in ascending order. Now the next thing that we are going to do, I'm going to create a variable of index over here, and I'm going to assign the last values index to this variable over here, because in this case after sorting them in the last value we will have the biggest element in the coins array. So it's going to be like this: int index is equal to coins dot length -1. So with this we are getting the last elements index from these coins over here. Then I'm going to write the loop like this: while true, we are going to get the coin value from the coins array. So in this case I'm going to create a variable like this, coin value, and it's going to equal coins with the index that we created over here. Then in each step we need to come backward from the last element to the first element. So in this case we need to decrease the index by one in each step. So it's going to be like. Then we are going to create another variable in which we are going to save the maximum amount. So after saving the maximum amount, based on this amount we are going to print out coin values to the console. So in this case maximum amount will be like this: int maximum amount is equal to, is going to calculate it based on this formula over here, n divided, this is the total amount, by coin value. So this is the value that we get from here. So I'm just going to copy it from here and pass it over here. So we are going to divide it by coin value and we are going to multiply it with coin value over here. So now for the first case, in the maximum amount we will have the amount of n. Now for the next cases we are going to decrease this maximum amount from this n over here. So after finding the maximum amount, for the first loop is going to be the amount that we have in the n. So we are going to put if condition like this: if maximum amount is greater than 0, in this case it means that we can print out this coin value to the console. So this means that we are taking it as a solution for coin change problem. So in this case it's going to be like this: system.out.print. So we are going to put coin value, then I'm going to concatenate the coin value that we have over here, and I'm going to count the number of counts that we are going to take this coin value. So it's going to be like this: taken count, because it's possible that, for example, for one element we can take it twice. So as we discussed in our previous lecture, for example, inside 2035 we have taken 1000 twice. So that's why here I'm just putting the count of the taken value. So the count will be calculated based on this equation over here, n divided by coin value. So with this we can identify how many times we have taken this coin value over here. Now after doing so, we are going to decrease n like this: n will be equal to n minus maximum amount. Then after this if condition, we are going to put another if condition over here, which will be the breakpoint of this loop over here. So when we reach the 0, we are going to break the loop over here. So it's going to be like this: if n is equal to 0, in this case I'm just going to put break. So with this we have successfully implemented coin change problem based on the algorithm that we discussed in our previous lecture. Now let's see how this is working in practice based on the problem that we discussed in our previous lecture. So here inside main class I'm just going to create an array in which we will have the coin values, and then we are going to run it for the amount that we run in our previous lecture. So it's going to be like this: integer type of array coins is equal to 1, 2, 5, 10, 20, 50, 100, and 1000. So as you remember, in our previous lecture, we have taken coins like this, and the total amount was 2035. So it's going to be like this. Integer amount is equal to 2045. And then for making the things clear, I'm just going to print out the available coins to the console. Then I'm going to print out target amount. Then we are going to call coin change problem for these coins and amount over here. So it's going to be like this: system out println. So I'm going to put coins available. So it's going to be concatenated arrays.toString. So I'm just going to put over here coins. Then we are going to print out target amount. So it's going to be system out.print. So we are going to put target amount. It's going to be the amount that we have over here. Then we are going to call coin change problem method for these coins and amounts over here. So it's going to be like this. So it's obvious that it's going to take as a first parameter coins over here, and as a second parameter will be the amount that we have over here. So in this case, it's going to be amount. Now, if I run our code, now you see that first it's printing out the available coins that we have in our array over here. So then it's printing out the target amount. Now here we can easily see that in the solution, it says that we have taken 1000 two times, then 20, then 10, then 5. So this was the solution that we got in our previous lecture. So as you can see, our method works the way that it should be. Now let's see what's the time and space complexity for this method over here. Now here in the first line, we are sorting the arrays using arrays class sort method. So in this case, according to Java documentation, it takes O(n) log n time complexity. Then we are creating a variable over here in which we are saving the last elements index. So this one will take O(1) time complexity. Then we have a loop over here. So this means that in the worst case, this loop will run n times. So it means that this loop will take O(n) time complexity. Now inside this loop, we are creating a coin value variable over here in which we are saving the coin value. So this will take O(1) time complexity. So decreasing index by 1 also takes O(1) time complexity. So creating maximum amount and assigning this value over here also takes O(1) time complexity. Then we have if condition over here, and the code inside this if condition takes O(1) time complexity. And at the end, we have if condition like this, in which we are checking that if n is equal to 0, we are breaking. So this one also will take O(1) time complexity. Now, if we combine all these complexities over here, in this case, it will take O(n) log n time complexity, because here we are sorting the arrays using sort method of arrays class. Now, the space complexity for this method in this case will take O(1) complexity, because here when we are performing coin change problem, an additional memory is not required. But in many cases, when we are performing coin change problem, we are returning the array with the coins that we have selected. So in this case, if that is the case, the space complexity will be OV, where V is the number of elements that we have in our return array. Now with this, we have come to the end of this lecture. So in this lecture, we have implemented coin change problem in practice using Java programming language. So hopefully everything is clear about this method also. So see you in the next lecture.